Oh, hi, everyone. Thank you for showing up for your learning. I am, as always, Mr. Jennings, your humble math servant. And today we're looking at the intercepts of lines. This topic 4.2, intercepts of lines. Ignore that 3.2. You know me in numbers. All right. So what we're looking at here is intercepts means where do these lines that are created by linear relations, where do they happen to touch the y-axis? And where do they happen to touch the x-axis? So if we look at this line here that goes off this way and off that way, we'll notice it intercepts the y-axis at that point. This is, of course, the y-axis here. And then it intersects the x-axis at that point. And the y-intercepts are always written of the form some value 0 and y. So this one here, if we read this as like the point 0, 2, that would be the y-intercept. 0 is always the x value for a y-intercept because all along the x-axis, the value of y is 0. And all along the y-axis, the value of x is 0. So over here, this x-intercept, it has a y value of 0, and its x value would be -2. Okay, so that's like I've gone -1, -2 in the x, so that's the point -2, 0. So when you see these types of points that have a 0 in them, those are intercepts. That's what we're looking at. All right, so let's take a look at these examples and give the intercepts as a set of points. There's going to be 2 different points for each one. Here, this one, I can see the y-intercept is there. So that's the point 0 in the x, 4 in the y. And then this one here is the x-intercept. So that's the point -2 in the x, 0 in the y. Don't forget, x is always first and y is second because alphabetical. And then let's go red here. So here, over here on this line, here is the y-intercept. So that's the point 0, 2. 2 in the y, 0 in the x. Here is the point 4 in the y, 0 in the x. So those are those intercepts. And one last set of intercepts. Oh, this one. Here is the point 3 in the x, 0 in the y. So that is the x-intercept. And then over here, this point. That point is a red herring. This point is the y-intercept because that's where it touches the y-axis. So we would call that the point 0 in the x, -2 in the y. That's the y-intercept. So that's how you find them from graphs. You look at them and find where they touch the axes. And now, what if we want to find the intercepts from an equation? Okay, well, if you're looking for an x-intercept, then you know that y is going to be 0 because y is always 0 for every x-intercept. So you just let y be 0 and find the x-intercept. If you're looking for a y-intercept, you set x equal to 0 because x is always 0 at a y-intercept. So you just input that value into your linear function and then you'll find it. So let's take a look at this one. This is a nice example because I created it and it's in y equals mx plus b form. M is what we looked at yesterday. M is the rate of change. Okay, and it can also be written as rise over run. Or if you like to roll your R's, this is very much fun, rise over run. And that is what M is. That's your rate of change or your slope of your line. But then the B actually gives you one of your intercepts. There it is there, -9. So let's try. To find an x-intercept, we're going to let y equal 0. So let's try that. 0 equals 3x minus 9. Okay, and now we're going to add 9 to both sides because we want to solve for x. So we have 9 is equal to 3x. And now we want to divide by 3 so that we get x is equal to 3. Okay, so that way for our x-intercept, we know that x is 3 and y is 0. Okay, that's the x-intercept. But now let's take this equation, move it over here, and we'll set x equal to 0. Y is equal to 3 multiplied by 0 minus 9. Well, 3 multiplied by 0 is 0. So that's just y is equal to 0 minus 9. So y is equal to -9. You see, doesn't matter the m or whatever the rate of change is, if I let x be 0, all that just goes away. And I'm left with y equals b. Y equals b. And so that's why b gives us the y-intercept. It gives us the point 0 in the x, -9 in the y. So that's our y-intercept. So that's how you find them with the y equals mx plus b form. But lines aren't always given to us in y equals mx plus b form. So if you have a line that's in what we'd call standard form, where you have your ax plus by equals c, these ones are called standard form. And to be honest, we work with it a lot less than we do what we call slope-intercept form, or y equals mx plus b. In any case, the process is the same. You're still just going to set these equal to 0 and solve them. And I'll show you a trick. If you have a line in this form, it's really easy to graph them. So we're going to graph all these lines just based on the tricks that I show you. So here, to find the x-intercept, let y equal 0. Okay, so it's going to be 4x plus 0 equals 5. So x equals 5 over 4. So the x-intercept of this one is 5/4, 0. So here is, here is the y-intercept. You would say, to find the y-intercept, you go 4x plus y equals 5. And now we're going to let x equal 0. So now we have 4 times 0 plus y equals 5. So that gives us the y-intercept of 0, 5, right? Because y equals 5, because this is just 0, right? So there's our two intercepts. And now I can graph that by graphing the point 5/4, 0. So 5/4 is a little bit bigger than 1, so it's about there. And then the point 5, 0. So 5, 0 is there halfway to 10. And then I go ahead and draw a straight line through those points, and that will graph the line. That's a really ugly line, but I hope you get the idea. We'll do a few more examples. X minus y equals 1. Let's find the x-intercept. So we're going to let y equal 0. So x equals 1. Now let's let x equal 0. Oh, sorry, that gives us when y is 0, x is 1. Okay, you can see that there. If I put a 0 in there, x minus 0 equals 1. Okay, but now let's let y be 0. Sorry, let's let x be 0 and find out what y is. So then we would have 0 minus y equals 1. And so then that gives us negative y equals 1. So y equals -1. So that gives us the point 0, -1. So now I can graph those 2 points. Here's the point 1, 0. And here's the point -1, 0, -1. And then I join those with a straight line. There's my graph of that linear equation, right? Now let's keep going with a couple more examples. 4x plus y is equal to -8. Okay, let's let x equal to 0 to find the y-intercept. So we have 4 multiplied by 0 plus y equals -8. Oh, y is just equal to -8. So that gives us the point 0 is x and -8 is y. So that's this point down here. Boop. All right. And then let's take a look at if we let y be 0. So that will be 4x plus 0 equals -8. Well, dividing both sides by 4 gives us x equals -2. So that is the y-intercept of -2, 0. So the x-intercept of -2, 0. So that's back over here. Okay, so now that I've got -2, 0, and 0, -8, I can graph that because I've got 2 points. Any 2 points are going to fix a line. So I just put that between those 2 points. There's that linear equation like that. Like this. All right. And then the last one. Okay, so here. First, let x equal 0 to find the y-intercept. So you have this equation is 0 minus 2y equals -10. Divide both sides by -2. To clear that -2 away, that cancels that, and you have y is equal to -10 divided by -2 is just 5. Okay, so that's the point 0, 5. And then x minus 2y equals -10, and now I let y equals 0. Okay, so that's going to be x is equal to -10, and there's that one. So that's going to be -10, 0. So I could graph those as well. 0, 5, that point, and -10, 0. So I put a straight line between those points, like that. Very straight, beautiful line. Very good. So that would be how that would look if you wanted to use these intercepts to get an accurate graph very quickly. And let's see one example of where you might get a situation like this coming up. If we knew Billy had a total of 70 cents in nickels and dimes, and we want to know the relationship between number of nickels and number of dimes, how could we use a graph and intercepts to interpret this situation? First, let n equal the number of nickels he has, and let d equal the number of dimes. Then this would be his money. 70 cents is equal to 5 cents multiplied by number of nickels plus 10 cents multiplied by number of dimes. Let's get the cents out of there because you all know that this is all cents. The units are cents. So now I can look at that equation and I can actually say, well, let's find an x-intercept. This equation just tells me how many nickels and how many dimes he has, but they're in a relationship. More nickels means less dimes. So let's let n, so this is going to be my, my nickels line, and this is my dimes line, okay? So let n equal 0. So we're going to have 70 is equal to 5 times 0, which is 0, plus 10 dimes. Divide both sides by 10, gives you 7 dimes. And what that means is if he has 0 nickels, then he has 7 dimes. So here is the number 7. That's 1, 2, 3, 4, 5, 6, 7. See that there? See how the scale is, every step is 2? So that's the point 7, 0. All right. And then let's let d equal 0. And that's going to give us 70 is equal to 5 times n plus 0. So now we divide both sides by 5 to find that 14 is equal to n. So that's the point 0, 14. That's right up there. And then I can use a straight line here to find all the different possible combinations of nickels and dimes. Okay, so here's an interesting one. That's 10 nickels and 2 dimes. That's 6 nickels and 4 dimes. That's 6 dimes and 2 nickels. Okay, those are all the different points along there, right? So this is 2 dimes, 10 nickels. This is 4 dimes and 6 nickels. And this is 2 dimes and sorry, no, that's 6 dimes, and 2 nickels. Okay, so those are all the possible points and possible combinations of change that he's got that he could have in his pocket. And yeah, we also have some over here like 1 dime and 12 nickels. That one is also on there, right? So these are all the different possible combinations. All right, and you could use this situation to analyze that and solve other problems, and you can graph it accurately very quickly just with 2 intercepts. So these are some of the reasons why this is a useful skill. Any questions, hit me up by email. Otherwise, thank you for showing up for your learning, and try all the questions today. We'll take them up tomorrow when I'm back. Oh, let's graph one while we're here. So here is 70 cents is equal to 5 multiplied by the number of nickels, but we used y for the number of nickels, plus 10 times the number of dimes. And so there's that line that I just showed you. There's 0, 14, and here's 1, 12, and then there's 10, 2, sorry, 2 dimes and 10 nickels, et cetera, all the way down to that other intercept, 7, 0. Right, so this is how it looks on Desmos, and it's the same as what we just graphed. All right, bye for now, everyone.